You're listening to DTFHN for July 9th, 2026. I'm your Factory Unlocked host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who mass-produce opinions argue about who gets to hold the wrench. Today's a day for open blueprints and closed fists. Let's get into it. $1 million, that's the fine. 5 states, years of litigation, an antitrust lawsuit backed by the FTC. And the penalty is $1 million split 5 ways. $200,000 per state. That's a rounding error. On a rounding error for a company that pulls in $50 billion a year. But here's the thing. The fine isn't the point. The cure is the point. The FTC just secured a settlement requiring John Deere to make its diagnostic and repair tools available to every farmer and every independent shop in the country. Not just authorized dealers. Everyone. And there's a 10-year compliance oversight window to make sure they actually do it. Every point. Pull this thread back to 1956. That's the year the Department of Justice forced IBM to sell its computers, not just lease them. Until then, IBM maintained total control. You couldn't touch the hardware, couldn't modify it, couldn't let anyone else service it. Sound familiar? The consent decree cracked that open, and what followed was the entire independent computing industry, whole companies, entire categories of innovation. Existed because IBM was forced to let go of the wrench. Deere ran the same playbook 60 years later, just with software instead of service contracts. They built tractors that farmers technically owned but couldn't meaningfully fix. The diagnostic tool. The thing you need to clear an error code after replacing a sensor. Was locked behind a dealer-only paywall. You could swap the part yourself, but the tractor wouldn't start until a Deere-authorized technician came out, plugged in their proprietary laptop, and pressed a button. That's not a repair service, that's a toll booth. What makes this settlement elegant is the anti-retaliation clause. Deere dealers are now explicitly prohibited from punishing farmers or shops who fix their own equipment. That provision tells you everything about what was happening before it existed. One of the reader comments nails the absurdity. If you ask 100 random people whether farmers should be able to repair their own tractors, you get 100 yeses. This was never a close call on the merits. It was a company with enough market power to ignore common sense until the federal government showed up. The real precedent here extends past agriculture. Every car with a locked ECU, every appliance with a pairing chip, every device that bricks itself when you open the case. They're all running Deere's playbook, and now there's a federal consent decree that says the playbook loses. The tools exist. Let people use them. Nature's own pesticide, but this one actually works the way you'd want it to. One of the reader comments on this story stopped me cold. A beekeeper writing that 80% of the job now is just fighting mites. Not tending bees, not harvesting honey, fighting parasites, and every treatment currently available makes the honey inedible. So you can only treat at the end of the season, which means you're watching your colonies suffer for months while you wait for the right window. That's the world varroa mites have created. These tiny parasites attached to honeybees, feed on their fat bodies, transmit viruses, and have devastated colonies worldwide for decades. Beekeepers have been locked in an arms race with limited ammunition. Chemical treatments that harm the honey, powdered sugar that only works on mites outside capped cells, and a constant grinding vigilance that burns people out of the profession entirely. Researchers at the University of Queensland may have found something genuinely different. They've identified peptides derived from spider venom that kill WWII mites while leaving the bees completely unharmed. The specificity is what matters here. Most pesticides are blunt instruments. They kill the target but damage everything around it. A treatment that can distinguish between a mite and its host at the molecular level is a fundamentally different kind of tool. Now, the open and closed question applies even to biological research. This work is coming out of a public university. The paper is published. The mechanism is describable, reproducible, testable by other labs. Compare that to proprietary agricultural biotech, where the compound is patented, the formulation is locked, and the farmer pays per application with no ability to understand, modify, or improve what they're putting on their hives. The architecture of how this research reaches beekeepers will determine whether it actually helps them or just becomes another input cost they can't control. Another commenter pointed to Paul Stamets' work using mycelium extracts to boost bee immune systems, published in Nature Scientific Reports and openly available. These approaches aren't competing. They're complementary layers of defense that emerged because the research was accessible. That's how progress compounds. One lab publishes, another lab builds on it, and beekeepers get options instead of dependencies. The path from lab results to hive-ready treatment is long and uncertain, but the underlying science is sound, the need is desperate, and the work is being done in the open. For an industry where most of the job has become managing a crisis, that matters. The bees need better tools. This might be one. Building better tools from what's available. Pause. That's also the move Meta just made, except their raw material is old RAM chips. 40% of Meta's servers are memory-starved. 40%. We're talking about a fleet of millions of machines, and nearly half of them are sitting there, bottlenecked, waiting on RAM they don't have. Meanwhile, somewhere in a warehouse, perfectly functional memory sticks are piling up from decommissioned servers because RAM outlives the machines it runs in by a factor of 2. The chips are fine, the sockets are wrong. This is the kind of engineering problem that sounds trivial until you realize it's a material science constraint disguised as a compatibility issue. You can't just slot DDR4 into a DDR5 board. The electrical interfaces are different, the timing is different, the memory controllers expect specific protocols. Jamming old DIMMs into new slots tanks performance. So Meta did what Meta does at scale. They designed a custom chip. They call it Vistara. It's a CXL bridge, Computer Express Link, that decouples memory from the server's native memory channels entirely. The older RAM connects through CXL as a separate memory tier, managed by custom software that decides what data lives where. The result? Old memory works in new machines without the performance cliff you'd get from a naive plug-and-swap. And they published the full path. ASIC design through OS integration through hyperscale deployment at ISCA this year. Run this forward. Every hyperscaler on the planet has the same problem. RAM is the most expensive component in modern server. Prices are climbing. And the upgrade treadmill means perfectly good silicon gets landfilled every refresh cycle. Meta just demonstrated that you can break the coupling between memory generation and server generation with a bridge chip and some clever software. That's not a trick. That's an architecture. Now, one of the commenters pointed to Marvel's off-the-shelf CXL memory expanders, which is a fair point. You don't need a custom ASIC to do memory disaggregation. But what Meta demonstrated is the full vertical integration, chip, firmware, OS support, fleet deployment, and then showed the receipts publicly. Another commenter wished for a consumer version, and honestly, the CXL ecosystem is heading that way. Give it 2 product cycles. The beautiful part is the economics. RAM that would have been e-waste becomes infrastructure. Server refreshes get cheaper. The environmental math works out too, though Meta probably cares more about the procurement math. Either way, the engineering is genuinely clever, and the paper is open. That's how it should work. Moving on. Microsoft bought GitHub in 2008 for $7.5 billion. At the time, the mass migration everyone predicted didn't happen. Developers shrugged, kept pushing commits, and figured nothing would change. 8 years later, some of them are finally leaving. And the reasons are more interesting than the usual corporate anxiety. Let's break this down to what a CodeForge actually is. It's a Git server with a web interface, some CI runners, and a permission model. That's it. Git itself is distributed by design. Linus Torvalds built it specifically so no single server would be a point of failure. The entire architecture assumes you can pick up your repository and walk away. GitHub's genius was making that unnecessary by being so convenient that nobody bothered. And that's the comedy. The tool built for decentralization became the most centralized developer platform on Earth. 90-something% of open source lives on servers owned by one company, which is owned by another company, which has its own interests in AI training, enterprise licensing, and co-pilot revenue. The Git part still works exactly as Torvalds intended. The social graph, the CI pipelines, the package registries, the identity layer. That's the lock-in. One commenter described running Gatia on a tail-scale network with Docker registries and CI runners. The whole stack self-hosted. Another pointed out that GitLab's Omnibus Docker image makes self-hosting almost trivial. These aren't people making sacrifices. They're people who realize the tooling caught up. Codeberg, Forgeo, Gatia. These are mature platforms now, not hobby projects. The most honest comment came from someone who said it wasn't about politics or AI or technical issues. It was about Microsoft. Just Microsoft. And look, that's a legitimate architectural concern dressed up as a grudge. When your entire development workflow depends on a company whose incentive structure can shift with one quarterly earnings call, you've got a single point of failure in a system designed to have none. But here's what I find genuinely exciting. The fact that credible alternatives exist at all is open source doing exactly what open source does. Git is open. The Forge software is open. The protocols are open. The migration path exists because nobody owns the format. A developer in 2026 can mass export their repos, spin up a Forgeo instance on a $5 BPS, and lose nothing but their star count. The tools exist, the switching cost is real but shrinking, and every developer who self-hosts is one more node in the network Torvalds actually envisioned. This one sparked some real debate, and honestly, I find the whole thing fascinating. WWII made a decision that would echo for decades. They took venture capital, went public, and suddenly a browser built by hackers answering to curiosity was a browser built by employees answering to a stock price. The engineering didn't get worse overnight. But the incentive structure changed, and incentive structures are gravity. Everything else just falls. Andrew Kelly, creator of the Zig programming language, just published his account of watching the same trajectory play out with Bun. Jared Sumner started in the Zig community with what Kelly generously calls beginner energy. Moving fast, learning by doing, producing imperfect work, but improving constantly. Builder culture at its purest. Then came the Teal Fellowship pipeline, the venture capital, and the pivot from open source project to startup with an exit strategy. Kelly's account is precise enough to be damning without ever raising his voice. Bun's codebase, as observed by the Zig team during their routine check-ins on user projects, was hacks on top of hacks. Abuse of assertions. Feature after feature, with no time for reflection or debt elimination. The code quality wasn't a side effect of speed. It was the product of an incentive structure that rewards demos over durability. Take the VC logic to its conclusion. You raise money, you need growth metrics. You ship features faster than you can stabilize them. You burn through engineers because your job posting literally warns them that work-life balance means not working enough. The talent pool, the Zig community members who would have loved to write Zig professionally. Steers clear. And eventually you rewrite the whole thing in Rust, because the technical debt compounds faster than the funding runway. The rewrite itself is almost beside the point. Rust versus Zig is a language choice. What Kelly is actually documenting is the moment when venture capital's gravitational pull overwhelmed a project's engineering culture. Bun went from a tool built by someone learning in public to a product built by a company optimizing for exit. One detail worth noting, Jared donated $60,000 a year to the Zig Software Foundation. He credited Zig on Bun's website. The gratitude appears genuine, but gratitude doesn't change gravity. Once the incentive structure points towards speed over craft, the code base follows. Every time. The architecture of the organization determines the architecture of the software. Conway's Law doesn't negotiate. Earlier, we talked about mass production winning wars. Well, someone took that literally and built a 2026 World War II Jeep. Every complex system I've ever built has had that moment, the moment where the parts are spread across the floor. Nothing fits. The deadline is real, and the only path forward is through. David Tracy just lived that moment with a ward gesture, ward, David Tracy. Just lived that moment with a ward, David. Quilt, getting with it that. Founder of the Autopene, serial wrencher, a man whose eBay purchase history reads like a parts catalog. Half joked to an eBay rep at an F1 race that you could build an entire Willys MB from parts bought on their platform. Months later, eBay called his bluff. The deal: assemble a brand new 1940s military Jeep from scratch in his driveway, then drive it 900 miles from LA to Moab, Utah, and run it on some of the hardest off-road trails in North America. 2 weeks before departure, the Jeep looked like an explosion at an Army surplus store. Let's pull this thread, because what Tracy actually did here is a masterclass in something builders understand instinctively. The Willys MB is one of the most consequential vehicles ever manufactured. Over 600,000 were built during the war, and the reason you can still assemble one from scratch 80 years later is that the design was never locked down. The U.S. government owned the technical data package. Any manufacturer could produce parts. The blueprints belong to everyone. That's why a brand new reproduction body tub exists on eBay in 2026. That's why Tracy could source a frame, axles, a Go Devil engine, a transmission, springs, shackle. The entire bill of materials. From individual sellers scattered across the country. This is what happens when designs stay open. The supply chain doesn't die when the original manufacturer walks away. It distributes. It persists. 80 years of aftermarket manufacturing, all made possible because nobody could put a lock on the engineering drawings. The craft here deserves recognition. Tracy is fitting original spec leaf springs, rebuilding a flathead 4-cylinder, torquing a transfer case together on his driveway floor. One of the reader comments nails it. No rust, no seized bolts, just pure assembly. The two things that make old vehicle work miserable. Eliminated. What remains is the engineering itself, and it is beautiful. 900 miles across the desert in a vehicle you bolted together by hand. That's not content. That's conviction. The kind of conviction that only comes from knowing every fastener personally. The tools existed, the parts were accessible, the knowledge was available. Tracy just had to build it. And he did. Moving on. What does it mean when a tool's biggest contribution isn't speed, but honesty? Cargo-nextest runs your Rust test suite roughly 3 times faster than Cargo-test. That alone would be worth talking about. But the engineering decision that matters most is per-test process isolation. Every single test gets its own process. If a test passes, it passed on its own merits. If it fails, it failed for its own reasons. There is no shared, mutable state bleeding between assertions. No phantom green check marks that only hold because test 7 happened to run before test 12. This is the question the Rust testing ecosystem has been quietly sidestepping. How many of your passing tests are actually passing? How many are just lucky? Lucky about execution order, lucky about shared state, lucky about timing. Nextest eliminates luck as a variable. And the fact that it does this while running faster, not slower, is a genuine piece of crap. The architecture is worth admiring. Nextest builds your test binaries once, then fans out execution across processes in parallel. The execution model documentation. And I say this without hyperbole. It's some of the best technical writing I've encountered in the Rust ecosystem. One of the commenters said it answered 90% of their questions on first read. That ratio almost never happens with developer tooling docs. Pull the thread on the community response and you find something telling. One user runs 32,500 unit tests through Nextest on CI without breaking a sweat. Another team forked it to add sidecar server support for integration testing. The author is in the comments, answering questions, calling it his best foot forward for how Rust testing should be done. This is what builder culture looks like when it's working. Someone identified a real problem, engineered an elegant solution, open-sourced everything including the reasoning behind the design decisions, and keeps showing up. The filter sets feature deserves a mention. A full expression language for selecting which tests to run. Filter by name binary, platform, any Boolean combination. For large code bases, this is the difference between running everything and running exactly what changed. CI minutes are developer hours. The math compounds fast. Nextest is MIT and Apache dual licensed. The source is on GitHub. The blueprints are on the table. If you're writing Rust professionally and you're still using Cargo-test's default runner, the interesting question isn't whether Nextest is better. It's why you haven't switched yet. We talked earlier about lowering barriers to entry. Here's a story that takes that idea and runs it straight into your browser. Let me make the strongest case against this. Browser-based simulators for robotics are toys. Real robotics requires real hardware. The friction of servos, the unpredictability of surfaces, the weight distribution problems that no physics engine faithfully reproduces. Anyone serious about robotics knows the sim-to-real gap is where ambitions go to die. A browser simulator is a science fair demo dressed up as education. Now let me take that argument apart. Consider how an immune system develops. A child raised in a sterile bubble doesn't build resilience. But a child who never encounters pathogens doesn't survive either. The immune system needs controlled exposure. Manageable doses of complexity before the full onslaught. That's what a browser-based simulator actually provides. It's not pretending to replace the physical robot. It's the controlled exposure that makes the physical robot useful when you finally touch one. Patoy builds open-source quadruped robot kit. Diddle, nibble. Small, programmable, walking machines with real servo actuators and sensor arrays. The hardware is genuinely impressive for the price point, but hardware has a cold start problem. You need the kit. You need to assemble it. You need drivers, firmware, a development environment. Every one of those steps is a gate where a curious 14-year-old decides this isn't for them. A browser simulator eliminates every gate simultaneously. No download, no installation, no waiting for shipping. You open a tab and you're programming a walking robot. The latency between curiosity and capability drops to seconds. This matters because robotics education has an access problem that isn't just about cost. It's about timing. The moment someone wonders whether they could make a robot walk is the moment they need to try. 2 weeks later, when the kit arrives, the spark may be gone. A simulator preserves that spark. Patoy's approach is worth noting structurally. The robot designs are open source. The firmware is on GitHub. The community builds extensions, gates, behaviors. Adding a browser simulator to that ecosystem means the entire pipeline from first curiosity to custom hardware modification runs on open tools. No vendor lock-in at any stage. No proprietary IDE you have to license. No walled garden where your learning belongs to someone else's platform. The sim-to-real gap is real. Nobody disputes that, but the curiosity to first attempt gap kills more robotics careers than any physics engine limitation ever will. Patoy just closed that gap to the width of a browser tab. We talked earlier about tools reshaping who gets to play. Well, Story 9 is about the time that reshaping toppled an empire. July 9th, 45 years ago today, a company that had spent nearly a century making playing cards shipped an arcade cabinet featuring a carpenter rescuing his girlfriend from a gorilla. The carpenter didn't even have a name yet. They called him Jumpman. He got the name Mario later, almost as an afterthought, borrowed from a warehouse landlord. That nameless carpenter in a throwaway detail is the entire story of how power shifts in technology. Let me make the case for Atari here. They had the home computer license for Donkey Kong. They had the dominant console. They had market share, brand recognition, distribution. By every rational metric, Atari should have absorbed Nintendo's hit the way a whale absorbs plankton. Metabolized it, gotten slightly larger, moved on. That's how incumbents work. But Atari CEO Ray Kassar got fixated on a contract dispute. Coleco showed an enhanced Donkey Kong running on their Atom computer at CES in 1983, exploiting what they saw as a loophole in the console versus computer licensing split. Kassar was furious. He went after Nintendo over the breach. And in doing so, he taught Nintendo's president Hiroshi Yamauchi exactly how the American console market worked. Which companies were vulnerable, where the leverage points were, and critically, that the incumbent was more interested in litigation than innovation. The Atom flopped. Coleco went under. Atari imploded in the Great Crash of 1983. And Nintendo, armed with everything it learned from watching American companies fight over its own intellectual property, walked into the vacuum with the Famicom. Rebranded as the Nintendo Entertainment System, the detail everyone misses is the Popeye license. Miyamoto wanted to make a Popeye game. Couldn't get the rights, so he invented original characters instead. Nintendo eventually did get the Popeye license, made the game, and it was fine. Forgettable. The constraint. The closed door of licensed IP forced the creation of something that couldn't be taken away. Original characters. An own universe. Mario, Donkey Kong. An entire ecosystem that belongs to the people who built it. The tools you're forced to build because someone else's door was closed. That's the bootstrap. So how do you measure whether someone can actually build? Story 10. Separating signal from noise in coding evaluations. One commenter nailed it so cleanly I almost want to end the segment right there. Quote, Fundamentally, aren't they concluding that tasks assigned to software developers, human or otherwise, are often incomplete, self-contradictory? Or worse, this is the world in which their tool must play. That's the entire joke. OpenAI spent significant engineering effort building an automated pipeline to audit Separan Bench Pro, a coding benchmark with fewer than 800 tasks. They deployed Codex-based investigator agents, ran multiple review passes, hired 5 experienced software engineers for independent annotation. The conclusion, about 30% of the benchmark tasks are broken. Overly strict tests that demand one specific implementation. Prompts that leave out requirements the hidden tests enforce. Tests so weak that half-finished code passes them. This has a predecessor. In 1994, the spec CPU benchmarks were the gold standard for comparing processor performance. Companies started optimizing compilers specifically for spec patterns rather than real workloads. The benchmark became a game you played instead of a measurement you took. The community spent years trying to patch it, adding new workloads, retiring gamed ones. The fundamental problem was never the benchmark itself. It was that the moment you define a fixed target, the entire ecosystem warps around hitting it. SWI-bench went from 23% pass rates to 80% in 8 months. Not because models got 3 times better at software engineering, because everyone, model developers and benchmark curators alike, was staring at the same 731 tasks, until the signal dissolved into noise. Another commenter pointed out that a handful of engineers could review the entire dataset in a week, which raises the real question. Why are we measuring the frontier of artificial intelligence against a dataset small enough for a book club to audit? The deeper comedy is what OpenAI recommends instead. They suggest developers carefully examine results on a benchmark they just demonstrated. Requires a multi-agent automated pipeline, plus 5 senior engineers to properly evaluate. The prescription is the diagnosis. What actually works is what one commenter proposed. Give a model $100 of API spend and measure what it accomplishes. Real tasks, real constraints, real resource limits. Messy, yes. Hard to standardize, absolutely. But you can't game a moving target, and you can't overfit to production. This has been your daily tech feed for Hacker News for July 9th, 2026. This podcast is entirely AI-generated. Scripts by Claude Sonnet 4.7. Voiced by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something with whatever you've got. We'll see you back here tomorrow.